Hello, my dear boys. Hope all of you are well by the grace of Almighty. Today, this is your online physics class. Welcome all of you to my physics class. Today, we will try to solve some questions, some board questions, especially 2020 board questions. Okay. So, my dear boys, our creative question is the length, width, and height of a brick is 25 centimeter, 12 centimeter, and 6 centimeter respectively. Mass of the brick is 2.25 kg. Density of water is 1000 kg per meter cube, and here given that the gravitational acceleration g equal to 9.8 meter per second square. Okay, so this is our given stem, and the questions are: A. Write down Hooke's law. Okay. B. Why the density of the water below and upper portion of the pond is different during hot sun. Okay. Question number C. Determine how much the maximum pressure acts on the surface by the brick. Okay. And question number D is whether it is sink or float when a pieces of same size wood of density 400 kg per meter cube placed in pair with the brick and put them into the water. Analyze mathematically. Okay, so this is a full set creative question. Now we will try to solve this creative question part by part. Our question number A is write down Hooke's law. Okay, the answer is within elastic limit, stress is directly proportional to the strain. Okay, within elastic limit, stress is directly proportional to the strain. So we can write stress equal to constant into strain. We can write that stress equal to constant into strain. Okay, so this is the answer for question number A. Our question number B is why the density of the water below and upper portion of the pond is different during hot sun. Okay, so the answer is we know that density of water varies with temperature. Water has its maximum density of 1000 kg per meter cube at a temperature of 4 degrees Celsius. When temperature increases, the density of water gradually decreases. During a hot summer day, the temperature of water of the upper portion of the pond is much more than the temperature of the water of the lower portion of the pond. So, the density is different between water of the upper portion and lower portion during the hot summer day. So, the density of the water below and upper portion of the pond is different during hot sun. Okay. Here, question number C is determine how much the maximum pressure acts on the surface of the brick. Okay, so here we know that the pressure P equal to force by area, or P equal to F by A. So here F stands for force and A stands for area. So here we see that the pressure is inversely proportional to the area of the object. So when the area will be minimum, the pressure will be maximum. So when the area will be minimum, the pressure will be maximum. Okay, now the force F equal to mg. Here m is given 2.25 and g is 9.8. By calculating this, we get 22.05 Newton. Okay, so this is the force acting on the brick. Now here the size of this brick is 25 centimeter, 12 centimeter and 6 centimeter respectively. So here the for area, the minimum two value is 12 centimeter and 6 centimeter. Okay, now we will use this area. We will use this minimum area for maximize the pressure. Okay, now minimum surface area A equal to 12 into 6 or 72 centimeter square. So we can write 72 into 10 to the power minus 4 meter square. Now the maximum pressure. So the maximum pressure P equal to F by A. Now F is 22.05 Newton and A is 72 into 10 to the power minus 4 meter square. So calculating, we get 3062.5 Newton per meter square. Okay, so the maximum pressure is, therefore the maximum pressure will be 3062.5 Newton per meter square. Okay, so this is our answer for question number C. Now we will try to solve question number D. Now we will try to solve question number D. The question is whether it is sink or float when a piece of same size wood of density 400 kg per meter cube placed in pair with the brick and put into the water, analyze mathematically. Okay, so for calculating this, first of all we need to determine the downward force. Here downward force is given by the piece of wood and the brick. Okay, here the mass of wood M equal to rho into V. Here rho is for the density of wood. Okay, here given that density of wood is 400 into the same size of brick, so 25 centimeter. Here volume B equal to length, breadth and height. Okay, 25 into 12 into 6 into 10 to the power minus 6 for converting centimeter to meter. Here there is 3 terms, so 10 to the power minus 2 into 10 to the power minus 2 into 10 to the power minus 2. So we can write 10 to the power minus 6. Okay. So calculating this, we get the mass of the wood is equal to 0.72 kg. Now downward force of the wood, Fw equal to mg. Here m is 0.72 into gravitational acceleration 9.8. Calculating, we get 7.056 Newton. Now total downward force will be Fw equal to force for the wood plus force for the brick. Okay. Now force for the wood is 7.056 plus force for the brick is 22.05 Newton. So calculating, we get 29.106 Newton. Okay. So this is our downward force applying by wood and brick. Okay. Now we need to calculate the upward force which is given by water. Okay. Now total volume, we need to determine the volume of the total displacement water. Okay. So total displacement, total volume of so now the total volume of the displaced water, total volume of the displaced water equal to volume of the brick and volume of the wood. So here length, breadth and height plus length, breadth and height same size. So we calculating, we get 3600 into 10 to the power minus 6 meter cube. Okay. Now upward force on the lower surface, upward force on the lower surface of the pair, F upward, or in short upward force, Fu equal to, here upward force is given by water. So here we will use the volume of displaced water and density of water and gravitational acceleration. So volume or displaced volume of the water is 3600 into 10 to the power minus 6 into volume density of the water is 1000 into 9.8. Calculating, we get 35.28 Newton. So analyzing this mathematics, we see that upward force Fu is greater than downward force. Force Fd. Okay. So we know that from the Archimedes law, if upward force is greater than the downward force, then the body will be float. Okay, then the body will be float. So the pair of wood and brick floats when it is put into water. Okay, so upward force is greater than upward force Fu is greater than downward force Fd. So the pair of the wood and float brick float when it is put into water. Okay, so this is our answer for given creative question. Okay, this is all from today. All of my dear boys is very much thankful for watching this online class. Thanks a lot, boys.